Hey, this is Mr. Beckstrom, and today I'm going to take a look at a problem from section 2.4. This one is similar to example number 9. And it says determine the following limit using positive infinity or negative infinity when appropriate, or state that it does not exist. So we can describe limits, one-sided limits, those are ones either coming from the right or coming from the left, as tending towards infinity, usually when there is a vertical asymptote at that x value. So it's going to look something like this, where, horrible line, so get that a little bit straighter. But let's say we have an x value right here, and the curve is coming up, getting really close to it. We say from the right it's tending towards positive infinity, and maybe from the other side it's coming down, getting really close from the left, and we say from the left it's approaching that x value from negative infinity. But sometimes when we're able to factor out this denominator, so if we had an x minus 3 factor on top, then it doesn't actually look like that. It actually will look just like a normal curve. At that x equals 3, there's just going to be a hole right there where x is equal to 3. And then it'll just actually approach some distinct y value. So we don't really know which one this is just by looking at it until we first kind of factor it. Or we plug the 3 in there and see whether we get the indeterminate form or whether we get a non-zero over 0. So that's the first thing I did. First thing I did was I just plugged a 3 in this function to see what I got. And I did that here. And notice I get a negative 4 over 0. So that is not the indeterminate form. And that usually means that I can't really do much with this. I'm going to have a vertical asymptote at the x equals 3. So the only thing that I really have to do at this point is see whether or not coming from the right of x equals 3, am I going towards positive infinity or negative infinity? So the next thing I did here was I factored the top, and you can do this in a couple of different ways. I factored the top here to x minus 1 and x minus 5 just by factoring this up here. If you need help with that, let me know and I'll send you some information. I kept the bottom. Notice this does not have any common terms, and we kind of know that because we had the non-zero over 0 here. And if I'm looking from the right of 3, just take any value that's greater than 3, like 4. And if I put a 4 in here, notice I'll get a positive number here, right? Just 4 minus 1 is 3, so I get a positive number there. I'll put a little plus. 4 minus 5 is negative 1. I'll get a negative number there. And 4 minus 3 is a positive number. I'll get a positive number there. So I'm going to get a positive times a negative is a negative, and a negative divided by a positive is a negative. So this thing is going to be a negative, which means that it's going to go towards negative infinity. All right, let's go ahead and verify that on our calculator. All right, so what I did was I went to the Desmos calculator here, and I put the original equation, which is in red here, and I also put in our asymptote here, which doesn't appear in the actual graph. This is just a tool for us to help graph this curve, and it's the vertical line that goes through our x value that we're approaching. So this is what it looks like. And notice from the right side of 3, we are indeed approaching negative infinity. And from the left side of 3, it appears that we are approaching or tending towards positive infinity. Now in the problem, they actually want you to factor this thing out and then find it from there. However, once you actually note that this thing is really not factorable and that you're going to have a vertical asymptote at that point, you can just go up to the original equation and take any value that's over 3. So you can just put 4 in here and you'll get a negative value, because 4 squared minus, which is 16, minus 24 is -8 plus 5, -3, and -3 over 1 is -3, so that's already a negative value, so you can just do it from there as well. But it's a good skill, and it's a necessary skill also to be able to factor it. And you'll see that if we put in any values that are really close to 3 on the right, that we will get a very small number, or a number that gets very close to negative infinity. That's the last thing I want to do. So let's take out our graphing calculator and just double check that as well. All right, so let's go in, and we're going to go clear out our old graphs or old equations here, and we're going to put this one in. And don't forget to use your parentheses. So we're going to have x squared minus 6x plus 5 divided by x minus 3. Oh, I got the divided by in there. Divided by x minus 3. All right. So this is our original function, and I want to take a value to the right of 3, but really, really close to 3, and make sure that I'm getting a pretty small number. So maybe -100 or -1000, but it should be pretty far down there. And the way I can do that is put the equation in my y1, and then I can say, hey, let's go to, we're going to hit vars, we're going to go over to y variables, put that y1 in there. So this pulls up our y1 equation, open parentheses, and we're going to evaluate y1 at 3.0001, something really close, but not exactly 3. That's really close from the right. And enter. And notice we get -40, almost -40,000. So definitely very, very small number. So all of these things are ways that we can kind of check to make sure that our answer tending towards infinity is correct. All right, if you have any questions, let me know, and I hope you have a great rest of your week. Thank you.